Hello students, in this module I will be talking about this key enzyme involved in transcription called as RNA polymerase or RNAP. Okay, let us see what is so special about this enzyme. Now what I've shown you here is a prokaryotic cell, right? In a prokaryotic cell like bacteria, there is a single RNA polymerase or a single RNAP which is involved in the synthesis of all three types of non-genetic RNA, namely rRNA, next mRNA, and third tRNA. You got that right? So you can say that in prokaryotes like bacteria, a single RNAP can synthesize all three non-genetic RNA, the rRNA, the mRNA, and the tRNA. Is that okay? But in eukaryotes, it is slightly different. Let us see how. Okay, so I have shown you here is an eukaryotic cell. Now in the eukaryotic cell also there is RNA polymerase, but in eukaryotic cell there are three types of RNA polymerase, each synthesizing a specific RNA. Is that okay? Let us see how. So there is an RNA polymerase 1 called as RNAP1. RNAP1 is involved in the synthesis of ribosomal RNA or rRNA. Then there's one more type of polymerase called as RNAP2. Now RNAP2 is involved in formation of something called as pre-mRNA. What is pre-mRNA? Pre-mRNA stands for precursor of mRNA, or you can also call it as premature mRNA. Why? I will tell you in a bit. Is that okay? Now this pre-mRNA is also called as heterogeneous nuclear RNA or hnRNA. So we can say that RNAP2 is involved in the synthesis of pre-mRNA or hnRNA. Then there is a third type of RNAP which is called as RNAP3, and RNAP3, you guessed it right, is involved in the synthesis of transfer RNA or tRNA. Is that right? Now remember, in eukaryotes there is a fourth type of non-genetic RNA, and it has a specific name. It is called as small nuclear RNA or snRNA. So the same RNAP3 is also involved in the synthesis of this fourth type of non-genetic RNA called as snRNA. So we can say that in eukaryotes, RNAP1 forms rRNA, RNAP2 forms pre-mRNA or hnRNA, and RNAP3 forms tRNA and snRNA. Is that okay? Let us see what goes on after transcription or post-transcription. Does anything happen to that RNA? Let us understand that. So I'm going to bring back this prokaryotic cell again. Now in prokaryotes, we know that RNA is synthesized or transcribed in the cytoplasm because there is no nucleus. Now in the cytoplasm, what you end up making is an RNA molecule, and this RNA is simply called as mRNA. It is made as is. There is no change or no modification required. So we can say in prokaryotes the mRNA formed is the mature mRNA which requires no further processing. But once again the case is slightly different in eukaryotes. Let us see how. In eukaryotes we know that the RNA is synthesized in that organelle called as the nucleus. Is that okay? Now in the nucleus, the RNA that we synthesize is called as pre-mRNA. Remember, the pre-mRNA stands for precursor of mRNA, or even you can call it as premature mRNA. Is that okay? Now this pre-mRNA looks slightly different if you look at it a little more in detail. This is how it looks like. It has two regions, right? I've shown you here in a cream and a pink color, right? And these two regions are respectively called exons and introns. Now, because the pre-mRNA is made up of two different regions, the exons and the introns, it is also called as hnRNA or heterogeneous nuclear RNA. Now, this requires some processing. Is that okay? So the pre-mRNA definitely requires further processing. And because I'm processing it after the process of transcription, I call this processing as post-transcriptional modification of hnRNA. Right? I will show you in the next module how this post-transcriptional modification of hnRNA takes place. Is that okay? So in this module, I talked about the enzyme RNA polymerase and how it is different in prokaryotes versus eukaryotes. And the next module, I'll be talking about the post-transcriptional modification of hnRNA. Thank you and take care.